Okay, we have to find out if this series converges or diverges. First of all, what would be the series here? Well, we have in the numerator just 1 always, so we don't need a variable there, clearly. That would just be 1. We're going to infinity, that's another thing we know, because of those 3 dots over there imply that we're constantly adding terms and following the same pattern. We tend to want to initialize our things at n equals 1, and now we just need to find out what is the pattern here. Well, it seems to be that these things are increasing by 4 each time. So to go from here to here, you add 4, then you add 4, then you add 4, and we're doing a series, and like a sequence, we're plugging in integers. We're plugging in the very next integer, 1, then 2, then 3. So it would only make sense that we're going to have a 4n in here, a 4n. But now notice that if we plug in 1 for 4n, we would get 1/4 as our first term. And our first term is 1/3. So how do we fix that? Just subtract 1. Subtract 1. Now check if that works. For the second one, yeah, it works because we plug in 2 and we get 8 minus 1, that would be 7 in that denominator. So for sure this is going to work. Okay, now that we have that, we can do our integral test. And we do our integral test because this is monotonically decreasing and because it's always not negative. By monotonically decreasing, I mean that each term in the sequence is smaller than the previous term the further you go. In the sequence, notice, not the series, because with the series you're adding. So the sequence is getting smaller because you're plugging in greater and greater numbers into here, so that your denominator is getting larger and larger, and therefore your entire terms are getting smaller and smaller. It's also always not negative because we're plugging in positive numbers from 1 to infinity, and you don't really have a negative here multiplying into it or anything. So it's always going to be not negative. We could do our integral test. Our integral test tells us that we can take the integral of this, and if our integral converges, that's what the series converges to. If it diverges, it means the series diverges. So we have 1 over 4, and I'm going to change the variable to x. 4x minus 1 dx. How do we solve this? Remember, this is the natural log of the absolute value of 4x minus 1. And then it's kind of like the chain rule with these integrals of this form. Just to make it quicker, you brought out whatever term you had here in division, so in the denominator, like that. Or you could write it as multiplied by 1/4, depending on your stylistic choice. So that's what the integral actually is, and we're going from 1 to infinity, but we can't do infinity in our integrals, so this becomes a t, and we're doing the limit as t approaches infinity, the limit as t approaches infinity, and we plug in here our first term from which we're evaluating, and we're going to infinity, but this is a t, and we're going from we're taking the limit on that. So this is the natural log of 4t minus 1 over 4, and we're subtracting this, which is the natural log of 4 times 1 minus 1 over 4. With the limit as t approaches infinity. If we plug in infinity into here, that's going to give us infinity. And infinity minus any constant over there, no matter what it is, it's just going to be infinity. So this is going to diverge. this divergence. That obviously, and we could have just based on intuition seen that that was going to diverge. You're just going to keep adding and adding numbers, and it just doesn't seem like it would reach an actual number if you start plugging in into your calculator.